Rahim. Assalamu alaikum dear students. This is our next problem. Problem having been once again chosen from the same book Modern Physics by Kenneth S. Crane. Okay. As usual we first come to its statement. Okay. Its statement is, what is the minimum energy of a neutron within bracket mc square equal to 940 million electron volt confined to a region of space of nuclear dimensions 1.0 into 10 to power minus 14 meter. Okay, dear students, actually as per fashion of physical quantities, this quantity, that is region of space of nuclear dimensions 1.0 into 10 to power minus 14 meter, is slightly irregular. Okay, as we have pointed out this thing many times, that in physics 10 to power minus 14 is less important or less meaningful instead of in place of 10 to power minus 15 or 10 to power minus 12 or 10 to ten to power minus 18. Okay, so anyhow, actually it should be 10 into 10 to power minus 15 meter, and we know that 10 to power minus 15 is femto. Okay, so anyhow we do not go in this slightly unnecessary discussion. Okay, we come to its solution as usual, as our practice. But first, before going to its solution in a formal manner, we will introduce helping tools. Okay, in this problem there will be three helping tools. Okay, first we come to helping tool number 1. Okay, in helping tool number 1, energy levels for a particle in a box En has been defined or described. Okay, energy levels for a particle in a box En is equal to Pn square over 2m, where Pn is the magnitude of momentum and m is particle's mass. Okay, this expression is equivalent to n square h square over 8m capital L square. Okay, these two expressions are equivalent. Okay, here h is Planck's constant and capital L is width of box. This expression once again alternatively becomes equal to n square pi square h cut square divided by 2m capital L square. Here, dear students, h cut is Planck's constant divided by 2 pi. Okay, when we put h over 2 pi in place of h cut, then we will come back to previous stage. Okay, that is n square h square over 8m L square. Okay, here n is quantum number 1 2 3 equal to 1 2 3. Okay, now we come to tool number 2. Okay, dear students, here one thing is slightly changed. Okay, what is the minimum energy of a neutron? Mc square equal to 940 million electron volt. Okay, Actually, as per tool number 2, neutron 939.6 million electron volt. Okay, so no difference almost, but actually in this tool or in this table, mc square for neutron is 939.6, and we know that when after decimal digit is greater than 5, then we can increase previous digit by 1 and round this figure. Okay, so in our toolkit, a table which includes this value contains this value as 939.6, but in statement of this problem this value has been rounded. Okay, this value has been rounded into 940 million electron volt. Okay, so this is no difference. Actually I have just clarified this situation. Okay, dear students, yes, in tool number 3 this table is shown. This table has been introduced many times in our previous problems. Okay, in this tool speed of light c is given, which will be relevant in this tool or table. Planck's constant h is given in two different system of units, and we will adopt second one. Okay, moreover, neutron mass mn equal to 939.6 MeV over c square. Okay, this is once again given. In previous table this value was also given. Okay, moreover, combined value of hc is also given as 1240 electron volt nanometer or million electron volt femtometer. Okay, h cut c is also given 197 electron volt nanometer or million electron volt femtometer. Okay, anyhow, now we come to its solution in a proper manner. Okay, we know that minimum energy refers to n equal to 1 in equation En equal to n square h square over 8 ml capital L square. What is this? This is the expression given in tool number 1. Okay, in which energy levels of a particle in a box were described or discussed or defined. Okay, dear students, actually here this quantity, that is region of space of nuclear dimensions 1.0 into 10 to power minus 14 meter, will be treated as width of box. Okay, L, capital L. In place of capital L we will use that value. Okay, however, for the time being we are not using that value immediately. We are just we have said that we know that minimum energy refers to n equal to 1 in equation this. Okay, so in this equation we will put n equal to 1 for minimum energy. Then this implies that E1 becomes equal to h square over 8 m capital L square. Okay, in the next step what we have done, we have made an arrangement in which we have multiplied and divided this expression by c square. Okay, so E1 becomes equal to h square c square, or we can write combinedly as hc whole square divided by 8 mc square. We write c square as a multiple of m within bracket, and write capital L square as a multiplying factor. Okay, in the next step we have used the value of hc which is given in our tool number 3 as a combined value. Okay, values of h and c also given in separately and also given combinedly. We have chosen combined value of hc from tool number 3. Okay, So in place of Hc we will use this value 1240 electron volt nanometer divided by 8 into mc square. In place of mc square, as per our tools number 2 and 3, its value is 939, but because in statement value has been rounded to 940, so we are not at liberty to prefer our tool over the value given in the statement. Okay, so in place of mc square we have used 940 into 10 to power 6 electron volt. Okay, because 940 million electron volt. In place of million we have used 10 to power 6, and in place of L we have used this value 1.0 into 10 to power minus 14 meter square. This becomes equal to, what we have done, we have simply taken square of 1240, which has become equal to 1537600. Electron volt square and nanometer square, it is quite obvious that when we will take square of this whole quantity, then not only the square of 1240 will appear, but also square of electron volt and square of nanometer will also appear. Okay. Moreover, when we simplify denominator, we come to these values. Okay, 752000000, okay, 7 zeros into electron volt into 1 into 10 to power minus 14 meter square. Okay, then just simplification, nothing else, just simplification. Electron volt 10 to power minus 9 meter square divided by this figure has already actually when its square will become minus 40 minus 28. Okay, and in place of nano we have used 10 to power minus 9. In the next step 10 to power 9 minus 9 will become in the denominator and will become 10 to power plus 9. And similarly 10 to power minus 28 will be shifted to a numerator and it will become 10 to power plus 28. Okay, so these changes have been made accordingly. Moreover, meter square will be cancelled from meter square. Okay, meter square, both meter square will be cancelled, and out of electron volt square 1 electron volt will be cancelled, but and only 1 electron volt will be left. Okay, so in the numerator 10 to power 28, in the denominator 10 to power 18, so difference 10 to power 10, and here we have changed this value into 7.52 into 10 to power 9. Okay, so just simplification, 2044680.85 electron volt. Okay, it can be written as 2.0 into 10 to power 6 electron volt. Okay, just we have reshaped this quantity. Okay, 2.0 into 10 to power 6 electron volt, and we know that 10 to power 6 is million, so in place of 10 to power 6 we can write m, so it will become 2.0 million electron volt. 2.0 million electron volt. So E1 has become equal to 2.0 million electron volt, and this is the end of our problem, end of our video. Till next video, Allah Hafiz.